objects, how objects are able to relate with each other, and how objects are able to interrelate or interlink with different views within the systems. So if you look at most of the things that we are supposed to discuss, we need to first of all work with definition of terms. And hope you can hear me, yeah?
Yes, I can hear you.
Okay, we will be looking at definition of terms, and we will start with the first term, which is object-oriented analysis and design. And I think this is not it is not new to you, because now you have done system analysis and design, where what you have discussed is analysis, and the next one that you have discussed is design. So if you can maybe share on this, analysis is collecting of evidence from users. And when you are collecting evidence from the users, you have to look at fact findings. And that's why if you look at the system analysis and design, we were looking at fact finding techniques. So one of them being, maybe you can use the questionnaire, sampling, etc. So the same way, when you are dealing with object-oriented analysis and design, here we have only included object. And when you include object, they have been oriented to a certain approach. But when you look at design, is now defining the requirements that you have already collected, and then you put them in a structured way that the users can be able to understand. I will not go to system analysis and design, because if you look at system analysis and design, we always look at an aspect of where you can now convert the analyzed data into a system. But for this one, we are looking at on how you can be able to come up with re-engineered options. So that's why we have now what you call the object-oriented analysis and design. So to define system analysis or object-oriented analysis and design, we always say it's a software or engineering model. And when you talk about model, we are talking about reality, real, something that is real, something that is having a process that you can be able to use in order to make some views within it. And this model makes use of objects, classes, state, methods, and behavior concept, so that we can analyze and demonstrate the system structure. So just look at a point where you are having a system in your institution, like now you are having ZTech University. So for this ZTech University, that is a system. The whole of the ZTech University is a system. And it has a process, it has some operations that are supposed to be done, those are methods, and it must have what you call state. Now, if you look at state, we are looking at now the time that you are now working on a certain event. Like now you can have a co-curriculum activity at that time. Nowadays, now we are having a class, that is a state. So we need to demonstrate it, and we produce what you call functional needs or behavior. And when you talk about functional needs or behavior, we are talking about something that can be used in reality, something that can be used to produce something. The next one is what you call object-oriented analysis. And I have sent notes on that portal, and I hope you have seen them, where if you look at object-oriented analysis, we are looking at emphasizing the things, how the system is supposed to do things. And in this case, we are looking at maybe the ZTech. What do ZTech University do? ZTech University is an institution sector. So it is supposed to do something that pertains to education. That is object-oriented analysis. What you do pertaining to what you are supposed to do within a given time. And when you're doing that, there are some orientations that are supposed to be done on that. So that's orientations are modules. So you find that now we have module like class modules, account modules, library modules, and many other modules. So when you try to combine these more modules that we are having, which we call object orientations, when you have library, then you have maybe we have learning, maybe we have accounting. Those three modules, when you combine them, now we are using a certain approach. And that is what you call the object-oriented approach. So the method of doing something. If it is registering, you are registering student, but that registering or that module that you are calling registration is the one that now pertains to what you call object orientation. And that is why we need to understand about object-oriented approach. And object-oriented approach is when now you take the behavior of a certain information or a certain module, and then you combine with another module, or we combine different processes within it, then we form a clear system. Like now, if you look at this, like university cannot work with only the accounting system. It has to work with accounting system. It has to work with exam, so that now we can have a process in it. So those two things that has been combined, exam and accounting, now that is what you call object-oriented approach, where we are saying it focuses in capturing the structure and the behavior of information system. What can we do with this? And that's why we always look at now, maybe those people who are coming up with Vika Superhighway, they came up with a certain approach. And this approach is connecting different truths, which can be used by different users so that they can be able to create effective system. Because now that is still a system. And a system, we always say that now a system is a component that interrelate with each other, or a component that work with another component to perform to do what you call processing management, so that we can come up with a clear system. And that is why, if you look at now, combining the system approach, what you have discussed here, you connect the analysis, whatever you have corrected, what the system is supposed to do. Then what the system is supposed to do, you take the behaviors through orientation. Then after that, you combine them through what you call object-oriented approach. Now, we are combining that through the use of what you call object-oriented design. And object-oriented design is to improve the quality and productivity of system analysis and design by making it more usable. If you look at ZTech University, there are some challenges. One of them is that now you find that we have some challenges in e-learning. Maybe users cannot log in within that system. So you cannot go and try to come up with an app and say, I want to solve this by adding bundles to users. No. What you can do, you first of all look at object-oriented analysis. You analyze the problem. And when you analyze that problem, now you take all the modules together. That is what you call object orientation. Then after that, now you combine those objects, where now you can create a tangible system. And when you create a tangible system is when now you are using what you call object-oriented design. The same way we define in system analysis and design, where we say a system analysis and design, or design itself, is now converting the analyzed data. So here we are converting the modules, and the modules are the objects. Because now, if you can now take accounting system, you take a registration system. Those two systems that we have, one of them is accounting, which now is an object. The other one, which is registration, it's another object. When you combine them together, we now come up with what you call a productive system. When can you say that you have a system which is productive? Mostly, we always say that you have a productive system if the system is able to work within the constraints, or the system is able to work within the domain. If it is an institution system, it is working within the domain of an institution. So that system, you can say it is a productive system, which is more usable within the institution, because you cannot develop a system for a school system. Then when you develop a school system, now it is doing what you call health management. It's working as a health management system. So for it now to be clearly stipulated, there are other things that you need to look at here. And one thing that you need to look at is what you call the object. Because system analysis and design, or OSAD, is always composed of objects, is always composed of classes, is always composed of polymorphism, is always composed of inheritance. In some cases, we say those are features of an object. So most features of an object, we have polymorphism, we have abstraction, we have encapsulation, we have data hiding, and many others that we have, of which we'll be able to discuss them as we progress, because there are some designs that we need to understand as we go through the unit. So when you look at the object as a defined term, we say it is a representation of an entity. What is an entity? And I think you have done what you call database management system. Am I right? Have you done system analysis and design? Hello? So if you have done what you call database systems, you can look at now some aspect that you can always be able to understand with these objects. And that's why we say it is an entity. An entity is a presentation of something, like a human being is an entity, like a chair is an entity. Why we call an entity? It's because it has some characteristics within it. And many other things that we have within that, we have behaviors. And these behaviors that we have, they portray some operations, which are these operations that we are supposed to work with these objects that we have. So we need to look at various aspects on these objects that we have. That's why we say it can represent something concrete, such as maybe we have Keman's track or concepts, such as a bank transaction. What can we do with a bank? A bank assists you in doing some transaction, withdraw, credit, maybe deposits, maybe get a loan, etc. Where each object is a system, and this object now has three characteristics. And that's why we always say, for you to define an object, we must define an object by using nouns, because nouns are used to represent places, are used to represent things, and within those things, you can be able to come up with various characteristics. One, maybe this is a person who is tall, maybe this is a person who is very big, or this person is very small, and we now can be able to represent an object in that way. So that's why we say, maybe a track is now an object, because a track has some characteristics. One, a track is white in color, a track is small, a track is very big, a track has 2 tires or has 4 tires, etc. If you can be able to define with different examples. Even a bank transaction. So you can withdraw, you can deposit, etc. So a bank now becomes what you call an object. Or a purchase order. What can we do with purchasing of an item? Maybe you can say you are buying 2 kg of sugar. You are buying or you are ordering 2 kg of sugar, etc. So in this case, purchasing order or order now becomes an object, because this is the term, or this is a thing that you have to look at when you are coming up with different presentation. Each object in a system has 3 characteristics, and that's why we are saying characteristics are presentations. Characteristics are presentation. If you can look at your notes or the notes that I'm scrolling here, we can say characteristics are representation of attributes. But now for this object, we are saying an object has a state. So when we say an object has a state, what are we saying? When you say an object has a state, we are saying an object has an operations or codations. Mostly we look at codations. Maybe when I am looking at this, I'm sitting, that is a codation. I'm standing, that is a codation. I'm walking, that is a codation. Then it has a behavior. what can it do? Those are operations. So when this object is moving, it is moving with 2 legs, or when this object is moving, it is moving with 2 tires or 3 tires or 1 tire, where an entity is a unique presentation. And when we say it is a unique presentation, we are saying an object has its own uniqueness. An object has its own representations. So we can say in conclusion and say an object has a given codation. There is an object X, which is an identity. An object X can move. When it is moving, now we are looking at a state of moving. When now we move from one point to another and we make some step, 1 step, 2 step, those are operations. Let's take a bank as an entity. Bank being an entity, bank has behavior. So you can withdraw money from the account. When you withdraw money, you require some conditions. 1, you must have an account, you must have an ID number, and those makes what you call a state. So a state can be something that constrains you from doing something or performing an operation, where now this operation, we are calling it a what? A behavior. So that's why we have said we can try to name other objects. Maybe we have students. A student is in class. Being in class, that is a state of being in class. But when you are in that class, what are you doing? You are learning, or you are smiling, maybe. Those are behaviors. So a class becomes a condition. A behavior now becomes when you say this person is smiling, this person is listening, this person is laughing. Those now becomes behaviors. So we have now introduced identity, who is a student. We have introduced a state, which is now a state is in a class. It can also be a time, maybe 2 p.m. That is time. It can also be maybe a room that you are in, and that's why we are saying a class. Behavior is now what you are doing with that state. But now, for this case, we must always be able to understand other terms, because now we are in introduction part. And that's why we always say that we have a class. And when you are defining a class, we always say that is a group of objects which has similar properties. Like now, if you are looking at a student, that's why we are creating a Moodle for students who are doing OSAD. So these students who are doing OSAD, they have the same attributes, because you have the admission number, you have the name, and many other properties that you have. So if you have those properties, you can say we are having a group of objects. So a class is a presentation of an object, in another word, or a class is a group of objects. And when you talk about objects, we are talking about object that has characteristics, which has the same characteristics. Now, I cannot be talking about teacher here, and then I talk about student. That is not a set. And I think you have looked at one of the units that we call object-oriented programming, where we say a set. And we say a set is a group. And being a group, we can say we have a set of students. And these students are doing or are listening or are working or are studying, because they have some characteristics. So for this concern, we still understand that, because now we are talking about a class, which is a representation of objects. It still has behaviors, because we have said an object has behavior, it has identity, it has state. In another term, we say that behaviors are methods, maybe withdrawal, deposit, because you'll be withdrawing etc. Now, for this case, we have looked at a class. And when you look at a class, there are things that we need to look at in a class. And for this class, we can be able to look at on how we can be able to maybe come up with a class, given that we have an entity called student. And I think you can see my page that I have opened here for a paint. Can you see this?
Yeah.
Okay, so because I want to demonstrate on a class that you can have, or what to represent a class, where a class is always presented with 3 items. And one of the items that you always have is what you call a class name. So we divide this rectangle into 3. One of them, we have the class name. So we have the class name. Then the next one, we have attributes. So if you go to the database, we call them fields. And I think it is clear on that. Then after that, we have operations. Let's represent operation with OP. So a class, the first class that you can have, maybe we can have a student class. But this student class has some attributes. This class, this student has ID number. This student has ID number. This student has a name. Let me represent with NM. This student have a course. Let me represent it with CS that you're supposed to do. So these are characteristics of a student. If you look at now in a database, we say that ID number becomes now a primary key, which now represent a single entity that uniquely identifies the student representations. But the student can listen. So listen or listening now becomes a method. So listening becomes a method. That's why we always present a method like that. And when you are representing this, maybe we represent this method, we can also say that a student can do an exam, maybe do an exam or does an exam. So these are brackets that I'm presenting with, and we can say a student, which is now identity, becomes identity, while this now becomes attributes, of which we have presented here. This becomes methods or becomes behaviors. Remember, we have talked about behavior. If you go to our slides, we have talked about behaviors. So in this case, we are saying behaviors that we are having is reasoning. But what makes this behavior, or what makes the student to reason? What makes the student to reason is now what we are calling a state, the time. The time that makes the student to reason, because there is some time that you not even listen to what I'm talking about, because that the time has already elapsed. So for this case, we understand that most of the attributes, and I don't want to escalate on this, we will be able to look at now either presenting attribute as with a presentation of what you call a scope, and I think you'll discuss this in OP or in Java programming. The moment we'll be discussing Java programming next semester. So when you talk about scope, we are talking about the availability of that variable. And the availability of this variable, we are saying it is either private, it is either public. Let me represent it with PB. When we say it is private with PI, we are saying it can only be accessed within that domain. But if you say it is public, we are saying it can be accessed outside and inside the domain. Let's now present a class. And the moment we are presenting a class, maybe using a certain programming language, we always say that we have a class name. And when you're having a class name, let me represent a class name with N. Then maybe if it is C programming, and I think you have done that, use the open curly brace. Then we have members inside, then we close the bracket. So for this case, we are saying, we can say we have a class called student. Let me represent student with ST because I have already presented that. So we have a class called, so we have a keyword class student. But this student, we can now have the members. And one of the member we say int, maybe we have int ID. Then we have a semicolon. If you are looking at now a programming language, then we can close that. Remember, I have two attributes. And because I have two attributes, if it is a name, I can represent it as a character. So I'm using class student, open the parentheses, then I use int ID number. Integer becomes a data type, and I think you have discussed this in C language, so it is not new to you. And if there is a problem, I think you can ask question on that. Maybe, is there any question on that?
No question.
So I think you are clear on that, Sirio. So if you have already started a class, we have a student, then integer ID, where int is a data type, but now we are using C language or C++ language. Then we close, and then we have a semicolon at the end. So the moment we are presenting this, we are saying the class that we have, or the class that we have already presented, we can now introduce what you call instantiation when you move to another method. So that's why we are saying I can have a class that we are calling a class student, which we have already presented a class ST with some members. And then these members, I have closed the members. Then after that, suppose now we have member like what we have already discussed here. We have said listen. The student is listening. So we listen. So this listen as a method, we are now using listen as a public. And the moment we are using it as a public, we can say we always present with a minus sign. So we can say minus sign listen. That's why I'm saying I will not escalate this to object-oriented programming, because now this one is theoretical. And the moment you'll be looking at programming, you'll be able to understand why are we using negative. We are using negative because this is now a public method. But the moment you use it as a private, we use a positive. Maybe we use a positive ID if we wanted to use it as a private. It will be used within the domain of that method. So for this one, let's try to understand a clear presentation of this object in this class in a way that we have already introduced what you call properties, or what you call the attributes. We have introduced behaviors, and these behaviors are the operation. If you talk about maybe a bank being an entity, where the attributes that we have within a bank, we can have one entity, we have customer ID, maybe customer number, or bank state, or bank name. We can have bank location, etc. Then operation, we have withdrawal, deposit. And that's those are the ones that we are calling them operations. But how will you relate these operations? So that's why within the object-oriented analysis and design, we talk about relationship. If you look at your notes, we have said an object is a group of, a class is a group of objects with similar properties, which are called attributes, common nodes, those are groups, set of students, behaviors, which are now called operation, and common relationships to the objects, and common semantic. Semantic means the meaning of that object. Yes, we are talking about withdraw. Are we withdrawing? Or we are talking about withdraw, then we are depositing. The moment you'll be looking at your systems, I expect you to come up with your object. And I think for now, we are doing what you call a proposal. So the moment you are coming up with your systems, I require you to come up with a certain objective. I want to do a system that does A, B, C, D. So those functional requirements are what we are calling semantics, because those are the meaning within a system. And for this relationship that you have, and I think we'll be able to borrow these relationships that you have within the database, because I know right now you are doing, you have done database. Am I right?
Yeah.
Have you done database, or you are doing this semester?
We already did database. Right now we are doing advanced.
Oh, you are doing advanced. So for database, we talk about relationship, like now one-to-one relationships. Then we have many-to-many relationship, etc. And sometimes we call them cardinalities or components. Sometimes we understand that relationships that we have within the database management system or database are the ones still borrowed in these classes. Because we can say, if you are having a class, you are having a class A, which already we have represented the structure, because in this unit still will be required to represent a structure of a class. We present a structure of a class, and now you can present a structure of a class using a certain programming language. I would opt to use maybe Java, or maybe you can use C language because you have done C language. So for this, I'm assuming that we have a class A and we have a class B. If we can come back to database, we are saying maybe this is a student and this is the staff database or the staff class. So this class is relating with this. But most of the functionality that we have within this class and another functionality that we have within this class, how are they relating? Is this class relating with one-to-many, or is it many-to-one? Where one relation of a class A is many relation of a class B. Well, we are saying, if it is a student, and we call this a class A as a student, and I have units as a class. So I'm having a class student, and I'm having another class called units. So we can say many students are doing many units, So the same relation that we have within a database are the same relation that we are supposed to have within here. But in this object-oriented analysis and design, in some cases, we will be looking at what we call associations. So this class is associated with this class, but which class is a parent of the other? So if a class is a parent, we call it a superclass, If a class is a child class, we call it the subclass, sub. So in this, we are having a student class and we are having a unit class, where a student class now becomes a superclass, where a unit class becomes a subclass. So most of the characteristics that we have here are interrelating. That's why we have a child class. And because now we have a child class, we are now creating some attribute from the parent class. That's why we have another term here. If you look at your notes, we have another term that we are supposed to define, which we call inheritance. I don't want to discuss it right now. Let us first of all understand this class in deep. So let us try to think of another class or another object that we have, because we have said most of these objects that we have are the ones that are now trying to bring us in a concept of understanding that class, or maybe calling them as a class. Maybe we have a government. Government now can be termed as a class. This government has some functionality. Maybe we have a government which has a government name. Maybe this government is Kenyan government, Eugene government, TZ government, etc. So those are now what we are calling attributes. When you come now to the operation, what are the mandates of this government? The government is supposed to safeguard people and the items within our country. So for this now, we are already presented what you call behavior operations. So for this class that we have, we can now relate, and that's why we have said these classes are relating to each other. And when they are relating to each other, they are now relating as either one-to-one or many-to-one or many-to-many. In some cases, and I think you have done this, we always say n. If you don't know the maximum number of relations that we have, but m, you know the maximum number of relations that we have. Well, we can say there is an association of one-to-one. There is an association of many-to-many. There is an association of many to non-existence. Because if you look at now n, we are looking at many to non-existence, many items presented on that. The next term that we are supposed to define within that, after understanding the structure of a class, is what you call polymorphism. If you look at the first definition that we are already defining, I said object has some features. And one feature that it has is what you call polymorphism. It has inheritance. It has abstraction. So this object can only be presented by presenting many forms. Now, I want to give a very simple example here. Let's say we are having a circle, or we are having a shape. So if we are having a shape, and this shape we are calling it maybe shape triangle, or maybe we are calling it a shape rectangle. Those are what we are calling shapes. All of them are called shapes. But these shapes can be presented by one name. We can call them shapes. So if you call them shapes, we have shape like triangle, we have shape like rectangle, and maybe we have a shape like circle. So we have a triangle, rectangle, and a circle. But the operations that are done on a triangle can also be done on a rectangle, and also can be done on a what? On a circle, but in different ways. If you look at a triangle, you can do what you call maybe calculate area. We can calculate area. When you go to rectangle, you can calculate area. When you go to circle, you can still calculate area. But if you look at now, an area of a triangle is now what? So you are looking at a rectangle, a triangle, and a rectangle. It is half base times height. If you look at this, it's length times width, pi r squared. So operations are different, but now the state of doing them is the same, because we are now calculating the area of a circle. So when you are presenting different views within a shape, those are the ones that we are calling polymorphism. So polymorphism is originally a Greek one that means the ability to take multiple forms, where you draw a circle. So draw a circle has many forms, a triangle has many forms, etc. So you can be able to do what? Draw a triangle, draw a circle, draw any other shape. But now the way we are drawing a triangle, the way we are drawing a circle is totally different. But the key one is what? Drawing. So that draw becomes a polymorphized object within it. So that's why we always say that most of the objects that we always have within our classes, we always create many forms or many operations in different entities or in different objects. Where this object is doing calculating the area, the other one is calculating still the area, and when they are calculating the area, they are only calculating the area with one operation, with one name called area. So that those are different forms, calculating area using different steps or different processes or different forms within that. I hope we are clear.
Yeah.
Are we able to understand?
Yeah.
Yes, Pauline, are you able to understand with Evans? Evans? Okay, I hope you can understand. So if you look at now, this presentation of various forms, we now create some relations within them. Because we have said, if you can have a triangle, you can have a rectangle, you can have a circle. Now, how are they relating with each other? It is relating with each other because we are now calculating the area of different shapes. So we can say they are relating because we are calculating the area. But they are relating in different ways or different forms. And that is why we need to discuss what you call inheritance. Inheritance is a way of looking at now different objects, trying to relate with each other in either similar ways or in a way that now purports to be similar. And that's why we say it is a mechanism for sharing similarities among classes while preserving their differences. So we are looking at a triangle, a rectangle, but do they have any similarity? Yes, they have any similarity. One similarity, we are calculating the area of a circle. We are calculating the area of a triangle. So the similarity is calculating the area. And that's why we have different types of inheritance. And I think if you look at your notes, you can see it. And one inheritance that we have single inheritance. Just take an example, maybe of a parent and a child. So we are having a parent and a child. Who is depending on the other? Is it the child who is depending on a parent or a parent who is depending on a child? Now, we have some issues here because a child will always depend from a parent, but a parent cannot depend from a child. So a parent become a superclass, but this become a subclass, where one parent or many parents, they are relating with many children or one child. Here we can say one parent is relating with many children because there are children that are related, they are depending from a parent. That's why if you look at now, if you come back to programming, we say we are having a parent class which extends. We use a keyword extends, and we will look at that the moment we will be looking at UML diagrams. So extends child. Or we can say a child class, because that is a subclass, extends a parent. So in another case, we are saying a superclass is the one that, a subclass is the one that extends a parent. Meaning, we are borrowing some characteristics from a parent class. We are borrowing some attributes from a parent class. If a child dies, let's say we kill this child, this parent will have a zero dependent. And when this parent will have a zero dependent, so this person will not give some attributes or will not give some characteristics to that class that we are calling a subclass because it has died. So if you have a shape, because a shape is now the parent class, if a shape dies, now we don't have a class. So we kill everything. And that's why we always say that let's try to create the structure of a shape class. If you go to programming, let's try to create that structure. And that's why if you look at my examples that I have here, we are having a student where student having scholarship. So this becomes a single inheritance, meaning one student always have a single scholarship. You cannot have two scholarships at the same time. You're only given one scholarship. Or many students or one student can be given only one. Or many students can be given only one scholarship. So we can have many scholarships, but we can have one student, we can have many students, but we cannot have many scholarships. So these are single inheritance. The same case to a parent, where we are saying a child inherit from a parent. There are some properties that you have inherited from your parents. We always say that now most of the characteristics that you find within your parents are now borrowed from those characteristics that you find in yourself are borrowed from parents. That's why you find that maybe if your parent is short or tall or big, sometimes you have to borrow these characteristics from that. But if you go to multiple inheritance, is where we are having two parent class or many parent class. Mostly we say two parent class, but there is only one class that is inheriting from those classes. Meaning that you cannot have a certain object and this object be totally treated as a single object. We must have two objects that now are joined together to form one object, which is a concrete object. Let's say we are having a wheel and a rubber. Then we have a tire. So if you combine a wheel and a rubber, we will form a tire. But suppose we have a wheel, we cannot form a tire. Let's say maybe we are having a course. Maybe if you have a course A, for this course A, you must have course A having unit 1, unit 2, unit 3, and unit 4. So in this case, we can say this is a single inheritance. Because we can say this unit, this course, you can have only one unit, which is done. Or we can have 2 units, which are done. But if now we are having a class, like now we have a school. So a school has accounting department, has X registration as a system, has X, Y, etc. But now you introduce one system. But this system, we can say it is an e-learning system. This e-learning system is combined by several objects within it. So if now we can be able to combine various objects to form one object as a single one, now that is when you are saying that we are now coming up with what you call a multiple inheritance, where we cannot use one component to form another component. You must combine 2 components so that you form one component. And that's why we are saying a wheel and a rubber. Because if you combine a wheel and a rubber, now you form a tire. Then we have hybrid. When you look at a hybrid, is when multiple objects which has the same characteristics are relating to each other. Maybe we have a student X who is doing business. There is another student who is doing IT. There is another student who is doing accounting. If you combine those students in that, they form what you call a hybrid inheritance. Because you find that an IT student borrows some knowledge from an accounting student. An accounting student borrows some knowledge from an IT student. So if these students are interrelating, or if these objects are interrelating and they are sharing some attributes together, they form what you call a hybrid inheritance. So hybrid from the word hybrid means we are now combining multiple presentation of objects, meaning object 1 has its own characteristics, object 2 has its own characteristics, object 3 has its own characteristics, but when you combine them, they have some commonality in them, meaning object A, object B can depend from each other. But if you look at in multiple inheritance, tire is one that is depending from the wheel and the rubber, but the rubber is not depending from the wheel. So if you do away with the rubber, we still have a wheel, but we cannot have the tire. But in a hybrid, if you have a student 1, or if you have an object 1, if you don't have an object 2, that one cannot be called a hybrid. If object 1 and object 2 is not relating, and object 3 and 4 is not relating, now we cannot have a hybrid. The next one is multi-level. A multi-level become, it's what you call the hierarchical, meaning there is the superclass. That superclass forms a subclass, and that subclass forms what you call a supraclass. If you remember that in system analysis and design. If you look at my example, you are saying an animal. All human beings are animals. So we are saying animal, from mammal inherits some characteristic from an animal. So for this mammal to be called an animal, it is because it has borrowed some characteristics from an animal. For human being to be called a mammal, it is because you have borrowed some characteristics that makes a mammal. Where we say a mammal maybe breastfeeds, or a mammal does X, Y, Z. So for this case, we are having a hierarchical, meaning human is the endpoint of inheritance. So we cannot inherit beyond human. We are now in a terminal point where we are not inheriting from a human, but we can inherit from, so we can say a human being is a mammal, where a mammal is an animal. So a human being is an animal, given some characteristics that you have already talked about, or the attributes that you have talked about. The next one that we have is what we call the hierarchical inheritance. And the hierarchical inheritance is where there is one class, the main class, that has multiple presentation or polymorphized forms or object, where we are saying a vehicle, we can have a land vehicle, a water vehicle, or an air vehicle. So when you are having a land vehicle, which are those land vehicles? We have car vehicle, we have a car, we have a bus. But for this case, if you can look at this, we are looking at a single entity presentation. And that single entity presentation is where we are saying a car cannot move on water. A ship cannot move on land. A ship cannot move on air. So for this case, all of them are vehicles. So we have one main class, which we are calling a superclass. And this class is now creating other presentation of entities, of attributes, but these attributes, they have their own unit presentations. So we have one, what you call a single unit presentation of land, a single unit presentation of water, a single unit presentation of air, meaning that all the presentation that we have on land, like now a car cannot move on water, a ship cannot move on air, and the same case there. So that forms what you call hierarchical inheritance, meaning there are objects that are relating on a single interpretation for that. That's why we say now, in most cases, when you'll be looking at now UML diagrams, we'll be looking at these forms, which are now presented as a polymorphism. Then we'll be able to look at now how we'll be able to inherit them. How will you inherit them? How will you create some association? How will you be able to create some interpretations? How will you be able to allow these objects to communicate to each other? So that now we can be able to form what you call inheritance beyond them, in them. And then after we understand about that, we'll be able now to understand that inheritance is one of the main points, or one of the main term that we will be discussing in all our diagrams that we will be drawing in our unit that we are discussing right now. The next one is encapsulation. If you look at encapsulation, it is defined in various forms. If you go to networking, we say it's abstraction. The same case, when you look at now encapsulation here, we talk about binding data, hiding. So binding, we can also say, or hiding data. So there are some attributes that we are presenting, or there are some behaviors that you find within a system that the users are not given out, or they are not portrayed to users. Like now, if you look at the moment you are registering using our university portal, we can see that we have the unit name, unit code, and submit. But we cannot see the operations that are done for you to be registered as a student. The only thing that you see is the message. So all the operations that are done on a system that you cannot see, they have been encapsulated. So that's why we are saying is the process of binding or hiding both attributes and methods together within a class. So when you look at now, when you are withdrawing money using a system, we don't see the attributes that have been used to create a system. We see those main functions. We see the password, you enter the password, you see maybe the account name, but you don't see how the account name is generated. We don't see that. And in this case, we say it has been hidden. That's why we are still going and explaining and saying, through encapsulation, the internal details of a class can be hidden from outside. But why do we hide data? That is the question that we need to look at. And in some cases, we call it abstraction. We hide data to avoid errors. Because if you can be able to display everything on a system, if you're looking at a student, the student can see everything that is working on a system. The student can see how the marks are graded in a system. Automatically, those students can change the information. And when you change the information, now that becomes a data that is now, which is not clear, which is not reliable. And we said, when you're presenting object, it should be reliable with different approaches that you use. So when you hide data, we are abstracting, we are hiding some irrelevant information to users. We are only providing relevant information to users. And that is what you call encapsulation, which permits the element of a class to be accessed from outside only through the interface provided by the class. That's why when you log in to your system, we don't see how the system has been created. We only see the interface. We can see the name of the unit, we can see the unit code, we can see submit, but we don't see how the unit code is joined with other classes in it, because there are some classes that have been joined. Because when you are registering, sometimes you are looking at this student as this student paid everything, or 50% of what you are supposed to pay. If you have not paid, this person cannot register. It rejects your registration. So what I'm expecting from you is that when you are coming up with your system that you'll be coming up with, I want you to hide, because you always hide data. We always hide data to avoid errors. We always hide data to avoid amendment of data by users which are not allowed to amend this data. And for this case, we can have a very reliable system. That's why we have said this object-oriented analysis and design will be able to create a very generalized system, which is very clear to understand, which can be able to perform different functions within that. The next one is generalization. We have two terms here, generalization and specialization. And there is a diagram that has been presented here where we are now presenting a vehicle and land, water, and air. Then we have capacity, of which we have already seen this diagram. But moving from bottom, we say that it is generalization. Generalization meaning that we have already created a unit test within the system. So that's why we are saying a process, the common characteristics of a class are combined to form a class in a higher level of a hierarchy. So this is where we have a subclass joining another subclass with another subclass to form the main class, which you call a superclass. If you try to remove one of the subclass, and we know that in programming, if you try to delete from the parent, automatically we delete everything. That's why we always try to delete from bottom, from the subclass. And if you can look at this diagram, we are saying the arrow points to where the from down to up, meaning that the subclass that we are having here as a car and the other one that we are having as a bus, if I try to remove a car, it will not affect bus. If I try to remove land, it will affect car and a bus. So in this case, we are trying to come up with unit presentation of elements. But a specialization is when you come from top to bottom. And that's why we always say that now in a specialized, we say is a reverse of a process of generalization, meaning we are moving from top to bottom. It's like we are narrowing down some procedures. We have the main system. This main system, now we try to come up with different presentation of or we try to come up with these modules, different modules, or these we are calling them object orientations. And this object orientation, then we try to come up with a smaller system, which is very hard. That's why we always say that when you're coming up with a system, try to come up with some modules. Let me come up with the first module, then I come up with the second module, then I come up with the third module. When I combine them, I form the the next module, which now allow us to come up with what you call the main modules, which we are calling it a vehicle, maybe if you use this example. So if you look at this diagram, we are saying we have generalized a class because a car has its own characteristic. A car is not a bag. Because if you look at a car, has its own present, maybe it's a mini car. There's a bus, a big car. If you look at a ship, it's not the same as a boat. So if you look at a ship, it has its own unit presentation. If you look at a boat, a ship, it has its unit presentation. So if you try to do away with a ship, it cannot affect the boat. That is what you call generalization. In this case, we can still interpret in this case where we say we are having a car, but this car that we are having, it has a steering wheel, it has a gearbox, and then we have a lever. So this steering wheel is controlled by these two things. So we can say we have steering wheel, then we have a gearbox, we generalize. So when we are generalizing that, we are saying we are forming a lever alone, a gearbox alone, where a lever can be combined now to so that a gearbox can work. A steering wheel cannot work if the gearbox is not working. So those are the things that we are trying to come up in a presentation. We'll give different examples as we continue with the diagrams that will be coming up with new MLs. But let us try to understand that now, this term that we are calling object-oriented analysis and design, where we have said it is a software engineering model which makes use of object classes, state methods, and behavior concepts to analyze and demonstrate system structure, functionings, and behavior. So if you look at what we have discussed here, we cannot try to come up with a very clear presentation of information if we have not presented a clear object, if we have not presented a clear methods that we have already denounced here, and we cannot come up with a clear system if now we have not known a subclass and a superclass in it. So for now, I think for my own interpretation, maybe we can stop at that, and now I can allow you to ask some questions for that topic that we have already discussed for now. Is there any question? So if you are asking a question, you can ask a question, please. Narasha?
I don't have a question.
You can ask a question. Just ask a question. How are the objects? What are the objects? Let me ask a question. Can you answer what are objects?
Yeah, I can.
Okay. Are we able?
An object,
Yes.
it's something that represents a concrete.
To represent a what?
Concrete.
Okay. You can say it represents a concrete, and mostly it's when you are looking at now, this is a presentation of a real object or a reality. Eh? Like now, if you look at a student, that is a real object. If you look at a chair, that is a real object. If you look at a phone, that is a real object. If you look at any other element that you always have, it is another real object. What about encapsulation? Anybody can answer that? Pouring. Is pouring in?
Yes, I am.
Okay, you can answer that. I see whether you are
just
in the
entered now.
You have entered now, but
Yes.
please, you can listen to that clip. Huh?
Let
What
me
have
ask
you?
Is this semester 3 or 4?
That is semester 3. Year 1, year 2.
Year 1, semester 3. Hello?
Which unit?
OSAD.
Yes, I can hear you. That is all. You're not part of it?
Because in your introduction, you said it's semester 4, so I was worried. I'm in semester 3.
Oh, no. It was a mistake. I'm sorry for that.
Okay.
I'm sorry for that.
Okay.
Okay. But it is also that. Okay. So can we continue?
Yes, we can.
So I want to introduce some Evans, are we together? Evans? Okay. So we are printed an object. Which attributes can you have? Narasha?
Sorry?
So if you're having a class like a school, which attributes can we have? Anybody can answer that? Yes. Let's say we have a school. Does it have an attribute?
We can. Yeah, it has. Like, let's say, course, a school can.
One. A school has.
Course.
Okay.
Students. Course students.
Okay. If you look at now, we are generalizing this. Becomes now a parent class. And if it becomes a parent class, most of the superclass that we can have, maybe we can have a course, maybe we can have accounting, maybe we have a library, etc., which are now becoming a subclass. So if you can draw an arrow from bottom to up, where we have account to top, where we have a school, we can say we are generalizing. Specializing is when you are moving from vehicle downwards. So for this case, if you're using an attribute definition of a, there are those who have the school ID. Like now, if you're talking about a school of IT, the school of business. If you talk about school of business, it has its own ID. Maybe you can have the school name. What the school name of which we have said we have business. So then we can have the school location. And the school location that we have is maybe we can say TRC, maybe we can say agriculture, pioneer, etc. So when you look at attributes, we are looking at now the characteristics. If I look at a human being, what are the characteristics of a human being? Maybe this person is short, this person is big, etc. This person is dark, this person is brown, and those ones now forms what you call an attribute. But what about the operation of a school? Let's take maybe a school of business. What are the operations that you can have on a business school? Anybody can answer that?
Maybe registration.
Yes, you can have registration because now you allow students to register in this school. You allow students maybe to do an exam in this school. Maybe you allow the student maybe to create some video conferencing or communication, etc. on that. So if you look at operations, those are the methods of a given entity. But is there anything, is it possible for us to encapsulate some operation? Which are the, like now, which business, maybe right now you are having your own proposal, and I think you have started your proposals. Have you started your proposals?
Not yet.
Not yet. Suppose now we talk about school management system. If I talk about school management system, you find that now you go to a library, then you go to the account office. But have you ever seen anything that is done on accounting system? The only thing that you see is the receipt. And the receipt has your name, your course that you're doing, and it has maybe the ID or maybe the school ID that you have. So sometimes you find that now, when you're coming up with any object, or when you're coming up with any presentation of an object, you can still do what you call encapsulation of these objects. And that's why we understand that most of the system that you'll be creating, because I know you will be creating your own system, you will be doing what you call encapsulation. And these encapsulations can only be done through what you call UML diagrams. And these UML diagrams are the ones that we are supposed to discuss. First of all, understanding what are UML, Unified Modeling Language. And Unified Modeling Language, these are the languages that assist you or allows you to create your own presentations. Like now, if you're doing programming, you cannot create your own programs. You must use structures that have already been provided for you. But for this UML, you can use your own structures. Like now, if I can use my own structure, maybe I can say, I have a structure called student. So I create a structure called student, and within student, I create some buttons within it. Maybe I say an embedded buttons. I call embedded button 1, etc. Then I close the that is a PHP, that is a HTML document. So we can now allow but when you look, we'll be creating this unified modeling language. Mostly we always say that unified modeling language allows you to interlink various systems. Like now we are having systems like ZTech Universe system. When you pay fees, you must go back to the school so that now they can accept your card or they can accept your receipt. But suppose now you are using a system that allows when you pay in a bank or using an M-Pesa, it interlink directly to the school. So that becomes an embedded system. And being an embedded system, it allows you now to interlink different users within that. It's not a must as a user, I go back to school. Automatically, my portal reflects that I have already paid the school fees. So for this case, we will be looking at on how we can be able to interlink this using diagrams. So that's why we always look at now, within the UML diagrams, there are things that we need to discuss. One of the things that we need to discuss is the thing itself. And when you discuss about the thing, we are looking at which are these structures that we are supposed to come up with. Which are these elements that we are supposed to come up with. So we must be able today, maybe we can start this next week so that we familiarize ourselves on what we have talked about here. Maybe familiarize ourselves on what we have done at this point. Is there any question up to that point? Any question?
No question.
Evans, do you have any question? Okay. So I think for now we can first of all complete with this. Maybe we go to chat room so that now we can be able to chat on various aspects, or maybe we can be able to add many other things. I will be using wiki. Maybe we can be able to understand. Maybe you can raise up some issues that are within there and given statements that are always be giving to you at this moment. So please, let's meet in a chat room and we can be able to chat. Are we okay?
Yeah.
Okay, sir.